Hi everyone, this is Miss Moore and today we are learning how to multiply and divide fractions. I understand that not everyone has a copy of the lesson template in front of them, especially if you're doing this lesson at home and you don't have a printer. So please grab a piece of lined paper or graph paper where you can record the most important theory and practice examples to use to help you when you're doing your assignment. Today's warm-up question is, generate as many ways as you can to solve this problem. What is 1/4 of 32? Try to come up with several different ways, and pictorial methods like drawing diagrams count too. Pause the video while you try this. I've drawn out 32 x's here to help us visualize the number 32. Maybe you used a visual method like what I'm about to show you, or maybe you used other forms of mathematical reasoning. So when we think about 1/4 of 32, I thought about how we can divide 32 into groups of 4. So 1, 2, 3, 4 groups. And then the answer would be how many x's or how many units are in that group, which is 8. So one way of saying this would be there are 8 units in each quarter, so 1/4 of 32 must be 8. Another way of thinking about this is that 1/4 is half of a half. So if we divide 32 in half and then take half of that half, we'll get 1/4 of 32, which is 8. Please take a minute and record all of the ideas that you had on how to reason this out on your page before we move on. So it turns out what we were doing in the warm-up question was multiplying a fraction by a whole number. But what does it really mean to do this? Here's another example, 1/2 of 6, or 1/2 times 6. Let's represent 6 using X markers like we did in the warm-up question. To find 1/2 of 6, we're going to have to cut this section of X's in half and count how many units are in that half. There's 3. Another way of thinking about this is, what is 6 divided by 2? 6 divided into 2 groups has 3 units in each group. Either way, you get 3. Let's try and connect this now to multiplying a fraction by a fraction. What is 1/2 of 2/3? Well, we can't represent 2/3 using X markers because X markers are for wholes. So let's choose a different type of diagram, like a pie chart, for example, and split it into thirds. Now we need to represent 2/3 of this diagram. Okay, so what's 1/2 of the pink shaded area? That's right, it's 1/3. So 1/2 of 2/3 must be 1/3. There's a trick to compute what we just did, and it works every single time when you're multiplying fractions. And that trick looks like this. If you have a over b times c over d, you take numerator times numerator divided by denominator times denominator. What would that look like for each of the examples that we just did? Well, up here we had 1/2 times 6 wholes. Where's the denominator? You guessed it. 6 wholes, or any whole number, can always be represented over 1. So if we do numerator times numerator, we do 1 times 6, and denominator times denominator is 2 times 1. So we get 6 over 2. And then that can be further simplified as 3. Let's see how that would work for our example with fractions. 1/2 times 2/3 is 1 times 2 in the numerator divided by 2 times 3 in the denominator, which is 2 over 6, which can be further reduced by dividing top and bottom by 2 to 1/3. Let's turn the page and do one more example together before you try some on your own. What is 2 over 7 times 2? 2 over 7, or 2/7, is our first fraction, and 2 wholes, or 2 over 1, is the second fraction. So numerator times numerator over denominator times denominator gives 4/7, which cannot be reduced, so that will be our final answer. Please pause the video here while you try the rest of the questions on your own. Okay, let's compare our answers. Now, I don't know about you, but when it came to this one, 15 over 70, to simplify that, I was kind of like, oh, mental math. So I'd like to show you a trick for making it a little bit easier, and it's called reducing before multiplying. The way this works is that you can reduce the individual fractions before determining the final product. You may have seen this done before, but I would like you to understand why it works. So if we have 3 over 20 times 10 over 9, we know already that that's equivalent to 3 times 10 over 20 times 9. But in the numerator, it doesn't matter if we go 3 times 10 or 10 times 3. I could rewrite it like this. And then just as we were able to combine it, I can also split it apart. And now we have 10 over 20 times 3 over 9. And that's equivalent to what we started with. And we know already that we're allowed to reduce within an individual fraction like this. 10 divided by 10 is 1, 20 divided by 10 is 2, and likewise 3 divided by 3 is 1, 9 divided by 3 is 3. So we end up with 1 times 1 over 2 times 3, or 1/6. Now, if we'd solved this the more traditional way, without reducing, we'd have 30 over, holy smokes, what even is 20 times 9? 180. Which, of course, you could reduce because both the numerator and denominator are divisible by 30. So this would also give us 1/6. Let's practice this helpful little trick on example 2 below. I'll do the first one with you and then you can try the rest on your own. 7 over 9 times 9 over 13 is equivalent to 7 times 9 over 9 times 13. Or 9 times 7 over 9 times 13. And 9 divided by 9 simplifies so that we're left with 7 over 13. Now this middle step here that I did where I switched the order of the numerator, you don't even have to do that if you don't want to. You can just simplify across like this. 9 divided by 9, and show your final answer as 7 over 13. So please pause the video here while you give the rest of the examples a try. Okay, let's compare our answers. And a few quick reminders: if you're working with mixed numbers, you need to convert them into improper fractions. Also, if you're working with negative fractions, you can just give the negative sign to the numerator like I did here, here, and here. And perform the calculation, and then afterwards when you're done, if your fraction is negative, you can leave the negative in the numerator, or you can write it out front of the entire fraction. And please don't forget that a negative times a negative is a positive. Okay, let's continue on to dividing fractions. And before we really get into it, I want us to truly understand what the concept of division means, and we'll start by doing that with some whole numbers. So what does 9 divided by 3 really mean? Represent it in words and with a model. If you want to, you can pause the video here and try it on your own. So this question is asking you, how many times does 3 fit into 9? Or how many groups of 3 are in 9? We can represent it with an X mark model. And if we think about the first approach, how many times does 3 fit into 9? 3 fits into 9 3 times, because you can make 3 groups that fit into 9. How many groups of 3 are in 9? 3. So either way you think about it, you get the same result. I'm just going to recap in words what it actually means. How many times does 3 fit into 9? And also, how many groups of 3 are in 9? Now let's connect this to fractions. If this is true, then what does 1/2 divided by 1/4 really mean? Well, it means how many times does 1/4 fit into 1/2? Let's try and represent this with a model, maybe using a pie chart model. How many times does 1/4 fit into 1/2? So let's represent 1/2. How many times does a quarter fit into this? There's 1/4 and there's another. So the answer is twice. Let's go back up to our first example of 9 divided by 3. 9 divided by 3 is 3, but is there a different way to get there? Is that equivalent to another mathematical operation that would get us there? In fact, it is. It's equivalent to 9 times 1/3, or 9 divided by 3. All roads lead to 3. Does the same process work when we're dealing with fractions? Well, 1/2 divided by 1/4. How are we going to get 2? There's a rule that always works when you're dividing fractions, and it is a over b divided by c over d is equivalent to the first fraction, a over b, times the reciprocal of the second fraction, which we get by flipping the numerator and the denominator. Let's try this on the example above. This would be equivalent to 1/2 times 4 over 1, which, now that we know how to multiply, we can express it as 4 times 1, which is 4, over 2 times 1, which is 2, and further reduce it to 2. Let's try some other examples. We'll do the first one together, and then you can try on your own. Compute the following quotients, being sure to change mixed numbers into improper fractions and reducing before you multiply. So now we're kind of doing all of our skills at once. 2 3/4 divided by 1/8. Let's start by converting that into an improper fraction. 4 times 2 is 8 plus 3 is 11 over 4 divided by 1/8. Using the division trick, we can express this as 11 over 4 times 8 over 1, and then multiply our numerators and our denominators. Unless you want to be working with big numbers, this is your opportunity to reduce. 8 and 4 are each divisible by 4. Unfortunately, we can't reduce the 11. So we end up with 11 times 2 in the numerator over 1 times 1 in the denominator, which is simply 22. Please pause the video here while you do the rest of the practice examples. Okay, let's take a moment to compare our solutions. And now that we're done, you can go ahead and start assignment 2. Please don't forget to check your solutions before handing in your work. Bye for now.